Hello everyone, my name is Harshitha and I am from Vijayawada. I recently completed my graduation from Seshadrirao Gudlavalleru Engineering College in the stream of Triple E, and with the help of Emertxe Information Technologies I completed my project which is washing machine simulation using PicsimLab, and here are the details about the project that I followed in the project.
See the contents of the project, that is introduction, embedded C, and in that keywords, data types, conditional statements, operators, arrays, structures, functions and pointers, microcontrollers, that are pins, inputs, outputs, timers, interrupts, hardwares used as switching circuits, CLCD display, fan buzzer. So these are the contents we are going to cover. Now first we'll see the overview of a C programming. So C is general purpose high level language that was originally developed by Dennis Emertxe to develop the Unix operating system at Bell Labs. So it provides fine grained control over hardware, making it highly efficient. As a result, C is commonly used to develop system level programs like designing operating systems, OS kernels, etc. So, some of the keywords used in C languages are auto, break, case, character, continue, do, default, double, else, enum, extends, for, if, go to, int, long, register, written, signed, static, size of, struct, switch, type def, union, void, while, volatile. So these are the commonly used keywords in the C language. Keywords means it is a predefined words. Next we'll go to the data types used in C languages. So the basic data types which are supported by C languages are integer, which is represented as int, floating point numbers, that is float or double, characters used as char, and void is used for void. So derived data types supported by C language is arrays, pointers, structures and unions. Enumerated data types allow you to define a set of named constant. User defined data types allow you to define your own data types using structures, union and type defs. So some of the operator used in C languages are arithmetic operator, assignment operator and logical operator. Arithmetic operator include addition, subtraction, multiplication, division and modulus. Assignment operator include assign, add and assign, subtract and assign, multiply and assign, divide and assign, modulus and assign. Logical operators used are logical and logical or and logical not, and the symbols are also included next to the words. Next is array. An array is a collection of elements of the same data type arranged in a contiguous memory location. So elements in an array are accessed using an index. So in every array it is accessed using the index value of an array, which represents their position within the array. Array have a fixed size determined at the compile time and cannot be resized during program execution. So the declaration of array is data type, array name and size of the array. The structure. Structure is a user defined data type that allow you to group together different types of data under a single name. So each element within a structure is called a member or a field. So the members within a structure can have different data types. Declaration of structure include struct name, in flower basis, member 1, member 2 and so on. So some of the conditional statements used in C languages are if else and switch. Under if else we have different categories like if else, if else if, nested if. If condition, if the condition is true it returns true. If else means if the condition is true it returns true, else it will return false. If else if the condition is true, it is true. If else, the second condition, if it is true, it is true, else it will go to the next. Nested if else, it is an condition within a condition, that is if else statement within a if else. Switch statement, it is an break which is used as case 1 break, case 2 break, and case 3 base a break, and last is default. So, embedded system, going to embedded system. What is the meaning of an embedded system? Embedded system is the combination of hardware and software, and the software is generally known as the firmware, which is embedded into the system hardware. Embedded C is used to program a wide range of microcontrollers and microprocessors. Embedded C requires less number of resources to execute in comparison with high-level language such as assembly programming language. So embedded C allows us to work with hardware devices like sensors and input-output devices. These are various embedded systems compilers. There are different types of compilers to compile the embedded C program, such as Keel compiler, SPJ compiler, embedded GNU C compiler, etc. So next is microcontroller. What is exactly a microcontroller? Microcontroller is a compact integrated circuit designed to govern a specific operation in an embedded system. A typical microcontroller includes a processor, memory, and input-output peripherals on a single chips. It is a computer on a chip and contains all the elements of a computer, such as electronic memory, input or output interfaces, and control processes. So this provides small size, reduced power consumption, and the ability to control after it has been programmed processes or events. Next is based on the bit configuration. The microcontroller is further divided into three categories, that is 8-bit microcontroller, 16-bit microcontroller, 32-bit microcontroller. 8-bit microcontroller means it is a type of microcontroller used to execute arithmetic and logical operations like addition, subtraction, multiplication, and division. 16-bit microcontroller, it is also a type of microcontroller used to perform arithmetic and logical operations where higher accuracy and performance is required. So 32-bit microcontroller, it is also a type of microcontroller generally used in automatically controlled appliances like automatic operational machines, medical appliances, etc. So PIC16F877A. So it is a popular microcontroller manufactured by Microchip Technology. It belongs to the PIC, that is Peripheral Interface Controller family of microcontrollers, and is widely used in various embedded systems and electronic projects due to its features and capabilities. So I have listed some of the features of this PIC16F877A microcontroller, that is, it contains three timers, namely timer 0, timer 1, and timer 2. It is high performance RISC CPU. It is 200 NS instruction execution, and it is CMOS technology, 8-bit up to 8 channel analog to digital converter. So IO ports. IO ports used are, there are 5 ports, that is port A, port B, port C, port D, and port E. Decision control register, that is tries A, tries B, tries C, tries D, and tries E. Tries A indicates the port A, tries B indicates port B, tries C indicates the name of port C, tries D indicates the name of port D, and tries E indicates the name of port E. Next, we go to interrupts. So it is a signal which makes the processor to stop its current task and proceed to execute. Handler set for interrupting sources. So the interrupted sources are, one is external and another one is internal. Classification of these interrupts are maskable and non-maskable. Maskable means it can be avoided. Non-maskable means it cannot be avoided. It can't avoid the type of interrupt. So timers. So in PIC 16F877A, it has three independent timers which can be used as a timer counter or PWM. So there are four. One is tick, resolution, quantum, scaling. Tick is based on the instruction cycle. Resolution is the length of the timer register. Quantum is the period of the tick. Scaling, it is a method where we can delay the process of going into ISR if required. So these are the timers used in PIC 16 F877A microcontroller. Next is CLCD. CLCD is a dot matrix liquid crystal display. It can be configured to drive a dot matrix liquid crystal display under the control of a 4 or 8-bit microcontroller pins available. So the pins available in CLCD is VSS, VDD, VO, RS, RE, read or write. So VSS is for negative supply, ground. VDD is for positive supply, that is voltage. VO is contrast control. RS is register select, that is 1 for data, 0 for the instruction. RE is read enable. Read or write is 0 for write and 1 for read. The softwares used for this project are MPLAB X IDE. So MPLAB IDE is a free integrated toolset for the development of embedded applications on microchips, PIC and DSPIC microcontrollers. It is called Integrated Development Environment or IDE because it provides a single integrated environment to develop code for embedded microcontrollers. Next is PicsimLab. PicsimLab is a real-time emulator of development boards with integrated MPLAB X bar AVRGDB debugger. PicsimLab supports some Pixim microcontrollers and some SIM8 AVR microcontrollers. PicsimLab have integration with MPLAB or Arduino IDE for programming the board's microcontrollers. So next is XC8 compiler. XC8 is a popular C compiler developed by Microchip Technology specifically for their PIC microcontrollers. It is used to compile C code into machine code that can be executed on PIC microcontroller. XC8 supports a wide range of PIC microcontrollers and offers optimizations for efficient code generation. So, let's go to the introduction to the project. A washing machine simulator using PicsimLab is a virtual environment that mimics the functionality of a real washing machine using PIC microcontroller simulation. So the washing machine simulation project aims to simulate the operation of a washing machine, including features such as selecting different wash cycles, setting water temperature, controlling the washing machine duration, and displaying status information on an LCD screen. Before going to the conclusion, I am going to explain the complete details of the project and also the working of the projects. So let's see with the code. So first I'll go to the code section. So MPLAB X IDE. It is a platform where we write the code. In this code we have two main folders, that is one is source file and header file. The source file includes the main.c. So now I'll show the program. That is, we have mainly three header files. That is, include clcd.h, include digital underscore keypad.h, include timers.h. So these are the three header files used. After this, we are going to initialize the values for the header files. That is, we will initialize the value for fan and buzzer as 0. Here 0 indicates off and 1 indicates on. So let us see how to build and clean the program. To build and clean the program, go to folder, right click on the folder. Here you will see the option like clean and build. Click on the clean and build the program with clean and build. So if the program does not contain any error, it will load like the clean and build is successful. So if the clean and build is successful, the program is neat with zero errors. This is the code part. Now we'll go to PicsimLab and start working on the project. This is the platform PicsimLab board. Now here we'll go to board and we'll select this pick GENIOS option. Click on this. So it will start. Then we'll go to microcontroller. Click on PIC16F877A option. Click on this, and also we select the clock size as 20 and LCD as HD44780 16 into 4. This 16 into 4 means that 16 words into 4 lines. Each line is divided into 16 characters or letters. So this is the options used here. If we want to extract the .hex file, we have to go for file. This is the starting point of the project. Here, the first step, we start with the keys. There are three keys namely used. So RB3, RB4 and RB5. RB4 indicates key 5, RB3 indicates key 4 and RB5 indicates key 6. So these are the keys used in this program. To start the program, I will be pressing RB4. So press key 5 RB4 to start the program. Now the washing machine is power on. The awning of the washing machine is done. Now if you want to go to the next option, click on RB3 button so that you can go to the next option. This button helps you to go to the next option, and one more thing is you have to press a short press so that it will go to the next option. If you click on the long press on RB3 button for 5 to 7 seconds, it will choose a particular option and it will work on it. So let us try. I will be clicking the RB3 button for 5 to 7 minutes. So let's see. So I have clicked RB3 button for long press for 5 to 7 minutes. Now it is showing me to select the water level. So there is 3 levels of water, that is auto, low, medium. So I'll select as low, and I will click on RB3 long press to select the water level as low. So I'll be clicking for low for 5 to 7 seconds. So I'll be clicking on the low. So I'll be clicking on this RB3 button for 5 to 7 seconds. So after long pressing on RB3 button, so it will ask for start or reset. The start button is RB4 key 5 button, and for reset RB5 key 6 button. So to start the program, I will be pressing RB4. So it will start the program. I'll set on RB4. So now the washing machine starts running. Here, if there is any interrupt in between. So this RB0, it is an interrupt key. So if you press on RB0 for long, there is a buzzer sound heard. This buzzer sound indicates the door is open and the door should be closed immediately. So after releasing this RB0 button, the program will be continued as usual. So the time is 1 minute 16 seconds now. After it completes, there will be another buzzer sound heard which indicates the completion of the program. So the main keys used here is RB3, RB4, RB5. RB3 indicates the key 4, RB4 indicates key 5, and RB5 indicates key 6. So RB0 indicates the interrupt key. So the remaining time is 50 seconds. After 50 seconds, the completion of the washing machine is done. Here we have port A, port B, port C, port D. These are the ports which we have seen in the previous PPT slides. So these are the ports used in PicsimLab board. Then next, remaining 30 seconds. In 30 seconds, the completion of the program will be done. So these are the heaters, buzzer, cooler. These are the options and other options available in the board. So we'll see how the completion of the washing machine is going to be done. So remaining is 12 seconds. So we'll wait for the completion of the washing machine. Yeah. Program is completed. The washing is also completed. It will go to the next level. That means if you want to reset, you can also click options used in PicsimLab, and these are the available keys used in this. So this is the working of a washing. So the conclusion is that the washing machine simulation using PicsimLab served as an effective tool for learning and applying concepts in embedded system. It offered hands-on experience that complemented theoretical knowledge and provided a foundation for further exploration in the field of automation and control systems. So in this way, the washing machine is used in by using the PicsimLab. Thank you so much.